Hello and welcome. You should be on page 33 of your pre-algebra quarter 2 notebook. In this video, we're going to talk about our introduction to functions. So let's talk about some key definitions. First key definition is a relation. And a relation is any combination of inputs and outputs. I also like to think of a relation as a set of ordered pairs. And if you remember, ordered pairs have an X and a Y. So 1, 2, 3, ordered pairs. Now, function. Introduction to function. So what is a function? A function is actually a specific type of relation. It is a relation, but it is a relation in which every input, or X, is paired with only, and that's the key, only one output, or Y. So one way to think about it, if you're looking, is that all of your X values will be different in the ordered pairs of a function. So, words that represent X values in math. Well, X values could also be called a domain. Domain is the same as saying values of X. X values are also thought as input, and X values are called the independent variable. Words that represent Y values are range. And I'm putting the words that kind of go with it, domain and range. Input, you can imagine this one is going to be output. And if the X values are the independent variable, Y values are the dependent variable. And you talk a lot about independent variables in science. Independent variables happen, whereas dependent variables, their value depends on what happens with the independent variable. So let's just look at these examples, and we're going to determine which is the independent variable and which is the dependent variable. When I look at this first equation, and this is a very special equation in algebra, it's a linear equation written in slope-intercept format. That's something we'll be looking at later, but just a little preview. And what I have is y is equal to 4x, and we know that this is 4 times x plus 5. So y equals 4 times x plus 5. Well, what this says to me is that if I put in a value for x, I'm going to multiply it by 4 and then add it to 5, and I will get y. So y will depend, it's the dependent variable, on the value of x. So y is your dependent variable, and x is the independent variable. Of course, we already said that the independent goes with x and the dependent goes with y, but that kind of is an idea why. Let's look at this one. C equals 2 pi r. You might not recognize this, but this is the formula for the circumference of a circle. That area, here we go, the circumference of a circle. So if C is 2 times pi, and pi has a predetermined value, or a constant value, pi is pi, and 2 is its own number, r is what could change. So your C, the circumference of your circle, is dependent. It depends on the size or length of your radius. R is the independent. Here's a situation. We got a car traveling at a constant rate of 60 miles per hour. So this is the rate, 60 miles per hour. if the time, that time, t, is increased, so if time goes up, distance also increases. So let's just think about this. If I spend more time driving, my distance will go up. So my distance depends on the time I drive. So time is independent, and the distance, or d, is my dependent. It depends on how long I drive. Okay, let's go to our next page, page 34. So just a few domain and range reminders. I just want to write here at the top of this page for us to remember that domain represents the x values, and that is on the x-axis, right? Whereas range represents the y values, or the value of where the point is on the y-axis. So we're going to look at these values. We know that a function is a relation in which each x is paired with only one y. And we want to look for situations where all of my x values are different. So let's look at number 4. I'm going to look at my x values. I have 1, 2, 3, and 4. Are they all different? Yes. X values are all different. So this tells me that every x is paired with exactly one y, so this is a function. Now, I want to state the domain and range. Remember, the domain is the x values. So just to state the domain, I am going to list in these fancy brackets my x values, 1, 2, 3, 4, and I'll list them in numerical order. That is the domain of this function. The range goes with the y values, so I will list the values of y in my function in numerical order, which is 4, 8, 12, 16. Let's look at number 5. Now, this is a table of values. This is what we call a mapping diagram. I am personally not a huge fan of mapping diagrams. I prefer looking and determining if something is a function using a table of values. So I typically will rewrite this into a table of values visually. It works a lot better for me. This tells me that the value of x1 goes with the value of 5. Now this tells me that 2 is paired with the value of y6, but there is also a pair of 2 that goes with the value of y7, and 3 goes with 8. So now when I look, we have x values that are the same. So this is not a function. So not a function. We could either write not a function, or it is just a relation. So this was not a function because I have 2 outputs, but they're not paired with only one input. Alrighty, we can still write the domain and range of this relation. The domain, again, is the x values. I list them in numerical order, and I do not list repeats. So my domain is 1. I only list the 2 once, and 3. 1, 2, 3. Now my range is my y values. Numerical order, I only list them once, but they're all different, 5, 6, 7, 8. Alrighty, final one. I've got a group of ordered pairs, a set of ordered pairs. So I have a set of ordered pairs. Let's look at our x values. I have a 0, a 1, and a 2. My x values are different. So this means we have a function. When I list the domain and range, first I'll list my domain. I'm going to look at my x values, and I'm going to list them in numerical order. I have 0, 1, and 2. Oop, I forgot the 1. 0, 1, and 2. Now, when I look at my range, what's interesting, my values of y, is that it's all the same. I have a value of y, 5, 5, and 5. I can be a function and have the same values of y, but I'm not going to repeat it when I list my range. I'm only going to write 5. So that's all for this video. We'll pick up with the rest of the notes in our part 2 of our introduction to functions. Thanks so much.